multiple choice questions, entropy, for year 13, obviously for physical chemistry. Obviously I've gone through what I've gone through now with you guys. Rate equations, I think all the multiple choice questions. This is thermodynamics. Once I finish this, and I'll finish acids and bases, and then I'll move on to your 12 physical content multiple choice questions. And just targeting the whole specification and finishing it all. Multiple choice questions. So in question 1, a reaction is exothermic, so that tells me delta H is obviously negative, and it also has a negative entropy change. Which statement is correct? The reaction is always feasible? Definitely not. The reaction is feasible. The reaction is never feasible. That's also incorrect. So it's either B or C. And if you think about it, we have got, obviously, we've got delta G is delta H minus T delta S. And we know delta H is negative. Yeah, because it's exothermic. We also know entropy change is negative. So we're doing a negative number minus T delta S, temperature time by delta S, another negative number. So the answer is the reaction is feasible below a certain temperature. And these type of things with reactions, exothermic and negative entropy change, I'd recommend just learning them off beforehand. Question 2. Now here's a classic question. Following information concerns an equilibrium gas phase synthesis of methanol. Equilibrium temperature 68 degrees, total pressure is that, number of moles is that. The standard entropy change for this reaction is, okay, so entropy change, we're working with formation data, the F there, it's going to be entropy of products, what we produce, minus entropy of reactants. And you have to know what you're looking for, because it gives you a lot of information. And once you realize, okay, all we looking for is the entropy of products, so entropy change equals 240 minus entropy of reactants 198 plus 2 of that. That's what we're looking for. So it's going to be first things first. 198 plus 2 times by, is that 181? 131. 198 plus 2 times by 131, and then just 240 minus my answer. Minus 220. There we go. A. So give you all that information, and all you had to do was that. So don't be fooled, don't be deceived by how much information they give you and assume that it means it's going to be a difficult question. Using information below answers this question. Standard entropy value for steam is, so H2O. Well, I know, okay, classic entropy change. I can also tell again, this is formation data, that little F is entropy of products minus entropy of reactants. But in this case, we have to do a bit of rearranging. It gives me the entropy change 138. Entropy of products 2Fe, so 2 times by 27 plus 3 H2Os, 3 Ys, let H2O equal Y, minus entropy of reactants 90 plus 3 times by 131. Rearrange it, find 3y, divide by 3, you'll get the standard entropy value for steam. So it's going to be, well, first things first, 90 plus 3 times by 131, 483. I've got 138 equals 2 times 27, 54, plus 3y minus 483, 54 minus 483 minus 49. So add 49, 138 plus 4 plus the negative version of my answer, and then divide by 3. 189. Question 9. In which one of the following reactions is a decrease in entropy? Okay, entropy. If it increases in entropy, more disordered particles, etc., etc. So what we're going to have to do is count the number of moles. So in part A, we go from 4, because we've got 3 here, and obviously that's going to be a 1 here, 4 to 7. In part B, we go from 2 to 7. I don't know what EDTA4 minus aqueous is. Maybe we learn about that in metal aqueous ions, I guess. But I have no clue what that is. 7 to 5 and 3 to 4. So it's clearly going to be C. We'll go from 7 moles to 5 moles. So clearly going to be a decrease in entropy. That is a really nice question though. Very nice question. Which one of the equations below represents a reaction that is feasible at all temperatures? Okay, well, you can see that there's clearly an increase in entropy here. There's clearly a decrease in entropy here. There's clearly an increase in entropy here. And there's clearly a decrease in entropy here. So let me just write that down for each one. Increase entropy change. Decrease entropy change. Increase. Decrease. Decrease entropy change. Now, if I know that it's an endothermic direction and that there's an increase in entropy, what I would have done is learn all of those key things off by heart. If delta H is positive, what will happen? And delta S is negative, positive. If the reaction is exothermic and has a positive entropy change, then delta G is always negative, since delta G is delta H minus T delta S. And it makes sense. Delta G equals delta H minus T delta S. And if reaction is exothermic, negative delta H, and there's a positive entropy change, a negative minus a positive, it's always going to be negative. So in the one that has that negative delta H, so exothermic, and an increase in entropy, positive entropy change. So the answer is going to be C. Bit of a tricky one. Question 11. This question relates to equilibrium gas phase synthesis of sulfur trioxide. Standard entropy change for this reaction is, given formation data, entropy change equals entropy of products minus entropy of reactants. So it's going to be entropy of products 2SO3. We obviously don't care about that. We're caring about the S, the entropy change data, entropy's data. So it's going to be 2SO3. So 2 times by 257, that's a product, minus 2 times by 248 plus 204. Obviously, I can't just put that all in the calculator. I'm going to have to do 2 times by 257 minus 248 plus 248 plus 204. I don't want to, make any math error on the calculator. And I should get minus 186 joules K to power minus 1 multiplied minus 1. Question 12. which one of the following reactions in aqueous solution has the most positive change in entropy? In entropy, go from 5 moles here to 5 moles here. We go from 5 moles here to 7 moles here. We go from 2 moles here to 7 moles here, and we go from 3 moles here to 5 moles here. And if you read the question again, which one of the following reactions in aqueous solution, that's not really relevant, has the most positive change in entropy? Entropy change is entropy of products minus reactants. So which one has the biggest difference? I was really asking. And therefore it's going to be C, because the change in moles going from 2 to 7, that's going to have most positive change in entropy. Question 13. It's a question about the reaction given below. Entropy data for the reacting species are given in the table below. Which one of the following statements is not correct? I don't really like that. It's just say false. Same thing, obviously, but I just like that. Which one of the following statements is false? The value of Kp changes when the temperature changes. I don't know how that's even relevant to this, but the value of Kp does change when the temperature changes. That is true. Remember, Kp, Kc, they only change when the temperature changes. The activation energy decreases when the temperature is increased. The entropy change is more positive when the water is liquid rather than gaseous. When the water is liquid. I think there's a mistake here. Two of them. Oh no, that's entropy, that's entropy. Entropy change is more positive when the water is liquid rather than gaseous. No, that's not true. I'm almost 100% sure that's not true. The activation energy decreases when temperatures increase. Increase the temperature. No, it's the activation energy. Minimum amount of energy particles need to react. No, I think it's clearly C. Anyway, let's finish it off and then we'll go to question 13. Question 14 refers to the following reaction. Which one of the following statements is correct? This is a redox reaction. I'm not sure about that, so let's move on to B, C, and D. Let's see if we can eliminate some, and then we'll move back onto that. The reaction is not feasible below 298 Kelvin. Well, delta H is negative, delta S is positive, and if delta H... One second. If delta H is negative and has a positive entropy change, then delta G is always negative, and therefore the reaction will always be feasible. So that's not true, because delta H is negative and entropy change is positive. At equilibrium, the yield of hydrogen iodide is changed by increasing temperature. At equilibrium, the yield of hydrogen iodide increases as the temperature is increased. So either C or D are going to be incorrect, or they're both going to be wrong, and therefore it must be A. And I'm pretty confident with C and D. Let's do it. So equilibrium, the yield of hydrogen iodide is changed by increased pressure. Increased pressure is going to shift to side with fewer moles of gas, because it's trying to oppose the increase in pressure by decreasing pressure. Shift to side with fewer moles of gas. Which side is the one with fewer moles of gas? Well, it's the same either way. So the yield of hydrogen iodide, I don't know, it won't be changed by increasing pressure. At equilibrium, the yield of hydrogen iodide increases temperature. Increase temperature increase. Forward reaction is exothermic. Backward reaction is exo. So if we're increasing the temperature, it's going to shift to the endothermic direction to oppose the increase in temperature, aka decrease in temperature. and therefore hydrogen iodide, well, that's not going to increase, that's going to actually decrease. So I'm pretty sure it must be A. This is a redox reaction. Now let's mark it. Question 1C, question 3A, question 6B, question 9C, question 10C, question 11C, question 12C, question 13B, that's 12, 13B, and question 14A. So 13 I got wrong, and 13 was probably the one I was least confident with, so it makes sense. And the correct answer was B. And it does make sense now, look at it. Yeah. Reason being is because, wait, it said which one of the following statements is false, not true. I fell for that same mistake again. Entropy change is more positive when the water is liquid rather than gaseous. That is true. Entropy change is more positive when the water is liquid rather than gaseous. Yes, because if you think about it, yeah, and which one is not correct? The activation energy decreases when the temperature is increased. The activation energy would actually increase. Anyway, that's the end of the multiple choice questions. Hope you find it useful.